Okay. As we said, these are approximations. Actually solve the equation. Okay, here we go. Remember the equation was y prime equals t square root of y. Well, I'm going to write this dy dt equals t square root of y. And I'm going to do something that needs to be justified, but I'm not going to prove it right now. Okay? I'm going to treat dy and dt like they're algebraic quantities. They aren't. But for the purpose of differential equations, we can pretend they are. Okay? You can get away with this. Sometimes you got to be careful, but you got to know a lot more to even know when. So we can arrange this as dy over t equals t dt, right? d by x squared, y, just divide both sides by square root of y, multiply both sides by that dt. We really can't do that, but we can prove that this is equivalent to this. Okay? And I'm not going to worry about the finer points of that. So the integral of dy over square root of y equals the integral of t dt. Okay, well, what's the integral of t with respect to t? Now that's second semester calculus, ought to be fresher.
Is it t squared over 2?
Yeah, good. So that's t squared over 2. You left off something important. You want to say what it might be?
dt?
Huh?
Is it dt? Wait, I don't
No.
know. What?
Huh?
I don't know.
Okay. What? I didn't hear what anybody said. You said something.
I said dt.
Yeah, well, I said that.
Yeah.
But then you said something
Oh, I
else.
said I didn't know.
Okay. I can accept that. You cannot leave off the integration constant. You know that. I know you know that. Okay? Now, dy over square root of y. Well, it's 2 square root of y. You can go back to the power function rule. You know, it's a negative 1/2 power. You've got to raise the power 1 and fix your constant, right? I didn't write my integration constant. Why not? Because whatever integration constant I have on this side can be subtracted from this integration constant to give me c. Okay? The integration constants absorb each other. So I can write it on either side. I don't have to write the integration constant on both sides. That would just complicate life. Probably deal with it, but it's easier. Okay? So, can you solve that for y? Okay? Well, I'm just going to do it. You get y equals the quantity t plus c squared. You multiply both sides by 2, and you get the t squared. It's t squared. What? Yeah. It's t squared plus t squared. Okay? You multiply t squared over 2 by t, you get t squared. And you multiply an arbitrary integration constant by 2, you still have an arbitrary integration constant. So you don't have to put a 2 in front of that c. Okay? It's different here than it is here. But since this is arbitrary, 2c is arbitrary, so just call it c. Okay? You don't have to change this letter or anything. Okay? Okay, well, what's the graph of t squared plus c squared look like? Well, it's going to look a lot like the 4th power of t plus a constant, but then you're going to have another t. So that's t to the 4th plus 2ct plus another c, and 2ct squared. And I do need to use the same letter here as here, because whatever this is, this has to be. Okay? And this is not just an arbitrary integration concept. This is arbitrary, but it's double. Okay? And this has to be the double of this, whatever this is. Okay? Now the value of c is determined just by your initial condition, that y of 0 is 1. Okay? That's part of the problem, right? Okay, now, I wrote y of t here. I didn't call it y of t up here or here because I was just doing the algebra with it. I can insert the t dependence anytime I want to emphasize it, and I can leave it off anytime I think it's safe not to emphasize it. Okay? It gets tedious writing the t here when you're just doing algebra with it. But when you get down here, there's our function. So now that y of 0 equals 1, what does this tell us about c? Well, if y of 0 equals 1, so c equals 1, right? Now, if we wanted to do y of 1/4, or y of 1/2 equals 1/4, we put the 1/2 in for t and set that all equal to 1/4 and find out what c has to be, right? Okay? So our function is the function we've been approximating. Okay? Now our last step our approximation was y of 0.2 equals 1.0301, right? Well, y of 2 is 0.2 to the 4th, and it's not 2c, c was 1, right? So that's just 0.2 t squared, right? Wrote that down carelessly. Watch me. I know what I'm doing, but don't always write things down correctly. It's just one of those things at age. I'm approaching 30, and you get old, and Okay, well, anyhow. Okay? Now what's 0.2 to the 4th? Well, 2 to the 4th is 16. So we're going to need like this. Okay? And check me on that. Yeah. I could be wrong. Happens a lot. Okay? 0.0016 plus 0.08 plus 1. Should be closer than that, so I suspect I might have done something wrong, although that almost never happens. We get 1.0816. We shouldn't be that far off. Now, there are all kinds of consistency checks we could do. Like, I could check the derivative of this thing, okay? You know, 4t cubed plus 4t, right? And if t is, oh, wait a minute. Hold it. Yeah, we got 0.2, 1.01. 0.2 squared is 0.04, double that, we get 0.08. The derivative of this thing, 4t cubed, 4 times t cubed plus t. If t is 2, it's like 4 times 0.2, 8. Okay, there's something wrong. Maybe in my algebra, maybe in the approximation, but I don't think so. Okay? So one thing I want you to do for homework is just run this out to t equals 1. Double check my solution here, it's very simple. Don't see what, you know, the derivative of 2 square root of y is 2 times 1/2 y to the negative 1/2, which is 1 over the square root of y. Derivative of that is t. Solving this, we double everything here and square it, expand the square, and that's very simple. There's something discrepant here, or maybe my intuition is wrong. Maybe it should be that far off. But here's a pretty small increment. However, the second derivative of this thing is pretty steep. And since we're underestimating it, we could be off by that much. My intuition doesn't like that. But the heck with my intuition. If the algebra is right and all the steps are right, that's a conclusion. My intuition is screwed up. Okay? And it does have a pretty drastic second derivative. And I can analyze that. If I have time, I will. Yeah. Just analyze the maximum possible value or second derivative, you put a bound on the thing and stuff like that. Okay.